Hello, welcome to our live lesson this morning, and we're here at Exa Networks in Bradford. Exa are an internet service provider. You might even be using Exa to connect to the internet to watch this live lesson right now. Speaking of the internet, have you ever wondered what the internet is, why it was invented, how, when, how fast it is? Well, we have a great lesson lined up. We have some technical experts who are going to help us understand all of these. But before we move on to that, it's important that we get you involved in our lesson because it is for you today. And the way we'd like you to do this is you can share things with us using the hashtag. But more important, we want you to engage and answer some questions using the Slido. And here's how.
To interact with today's stream, use the Slido track to the right of your screen. Downloadable resources are also available during and after the lesson.
So Slido is the way that we want you to engage with what we're doing today. You can interact. You'll see polls, there's a word cloud coming later on. And later we are going to have some experts who work with the internet joining us. And you can send them questions using the Q&A. Now, World Wide Web, the internet, are they the same thing? Well, some people would lead you to believe they are the same, but actually let's unpick them. So the World Wide Web, or the web as we call it, it's about 30 years old. And that is the software, the websites, the search engines. So when we talk about the web, that's what we mean. But when we talk about the internet, well, it's not 30, it's 200 years old. It's the infrastructure, the physical connections that join computers all over the world together. It's almost like the railway lines that carry the traffic that is the web. But sometimes people use the word internet when they mean both. But today we are focusing on that infrastructure. What an amazing invention this internet thing is. It is an amazing invention, really, when you think about it. But who invented it and why? Well, that's one of the things we want to share with you today. So, if we really want to understand what the internet is and when it was invented and why, we need to go back into history just a little bit. Back to the 1800s? Well, I've done that. So recently I visited a museum here in Bradford, the National Science and Media Museum, because I wanted to find out about the original start of the internet. So here we are, the National Science and Media Museum in Bradford. Follow me, we're going to go inside. So I'm here now in the Victorian parlour. Now, 200 years ago, if you wanted to send a message to somebody who was not in the same room, but maybe a few miles away, it could take days for that message to get there and days for the message to come back. Imagine if you wanted to send a message from this country to another country, like London to New York. Well, it would have to travel on a ship. The ship might take 10 days to travel across the ocean. And that was if the weather was good. All until a gentleman by the name of Samuel Morse devised this system, the electronic telegraph, and over wires using a system of dots and dashes, the beep, 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 beep. Messages could be sent in hours rather than days. And this system, it was so amazing, such a breakthrough, it was used for a good 100 years after Samuel Morse died, well into the 1970s. So it is recorded that on the 16th of August 1858, Queen Victoria sent the very first telegraphic message across the world to President James Buchanan, extolling the virtues of this magnificent, wonderful invention and how it was going to change the world. James Buchanan replied saying he also agreed it was a magnificent invention, and he hoped that everybody would have access to this network and it would only ever be used to do good. Now, that first message contained 110 words. It took 16 hours to send the message. It still took a long time, but it was a lot faster than 10 days. So, there we go. The internet was first started with this electronic telegraph that Samuel Morse invented back in the 1800s. And we now know it's largely a network of wires and cables that join computers all over the world, most of it under the sea. Now, I mentioned today's live lesson is about a few things. It's about trying to understand this infrastructure that we call the internet and how it came into be. But the thing is, how can you understand something that you can't really see? That is a bit of a problem for us, because a lot of the internet, and there's a reason why, is actually hidden from view. How are we going to understand this thing that we can't see? Oh, that's going to be so difficult. Is it really true that most of it is hidden from view? Well, you remember I said earlier that we are asking you questions today via Slido. Well, here's going to be our first Slido question now coming up. And in this question, we're asking you, what proportion or what percentage of the internet do you think is hidden from view? Because this lesson is live, we really want you, while you're sat there in your classroom, to join in. And that's what we're using Slido today to do. So, your answers are coming in now. That's great. We'll go and talk about your answers in just a moment. But don't forget, there's another thing you can do, this Q&A. You can send some questions in that we can ask our internet experts when they join us later in our live lesson. Oh, we've got people joining us from all over the world today. In fact, we might try sending a message to some of those parts of the world. We've got people joining us from around the UK. So we have people from, we have people from Wales and Scotland. We have people in England. We have people in Northern Ireland, Lithuania, Romania. We've even got some people joining us from Australia. More about that a little bit later on. Now, something else I didn't mention is, if you can't think of a question, you can have a look at the questions that other people have sent in and you can vote some of those up. So maybe I saw a question earlier about the difference between the World Wide Web and the internet. If you think that's a good question, you could vote that up. Now, we mentioned earlier that today we are here at Exa. I'm an employee of Exa. And Exa's job, or their products or their services that they provide, is they are an ISP. Internet Service Provider. So if we're doing a lesson about the internet, this is a good place to be in. An internet service provider. Yes, so what they do is they provide internet service to their customers. And do you know who most of their customers are? Well, if you look around the room right now, you're probably looking at some of them, because Exa provide their internet service provision mostly to schools, to education. So you might even be watching this live lesson right now, coming across the internet or under the sea via an Exa internet connection or one of those other ISPs. Now, we asked you a question. We asked what proportion or what percentage of the internet is hidden from view. I'll be honest, this is quite a tough question to answer because people say, well, how do you measure something you can't see? But people do say close to 100%. So those people who chose the top answer. But you know what, if you chose 92, you weren't too far away, but did anybody really choose 12%? And I suppose one of the things that kind of confuses people a little bit, people talk about, oh, it's in the cloud, it's all in the cloud. And I think that leads some people who claim to be experts in the internet to thinking, oh, cloud in the sky. Actually, very less than 1% of the internet travels through the sky, because more like 100% travels under the sea. Somebody showed me a really good website yesterday. I'll have to find the URL. Something like submarine cable map or something like that. It's brilliant. You can see all of these cables. Well, it's a map, a visualization about how they travel under the sea. That seems so bizarre to imagine, but actually that is true. Why? Why would they put it under the sea? Well, some of it does go under the ground as well, and maybe even in the ceiling in the room or a cable. But why? Well, think of it the other way. What if it wasn't? What if these cables just traveled across the land or in the room that you're in right now? Well, it could get damaged. Somebody could accidentally pick up a scissors and accidentally cut through it, and then everybody would be like, no, my internet connection is being cut. So by burying it in the sea or in the ground, in the street, it's protected. You would hope so, wouldn't you? And then your internet connection will be protected as well. Did I say buried in the ground? Well, here's a curious fact. Later today, you may be walking along a pavement, and when you're walking along the pavement, look at the pavement below your feet, because you're probably about a meter, actually probably less, probably 30 centimeters, 40 centimeters away from the infrastructure of the internet. It runs below the pavement that you're walking on. And sometimes what you can actually see is you can see these metal grid things that you walk on, and when you're walking on that, there's a junction box below, a junction box where all of these internet connections are joined together. Now, I'd love to be able to show you inside one. Well, what we're actually going to do, we have a bit of a treat for you now. We're going to go live over to a special kind of school. You could call it a school, but it's more of a training center. So there's a company you've probably heard of called OpenReach, and they have to train their engineers in how to join connections together on the internet. So this school, this training center is here in Bradford, and there's a colleague of mine that we're going to say hello, and she's over there live, and she's going to show us what it looks like in one of these junction boxes. So we are now going live over to Samia.
Thank you, Alan. I'm Samia, and I'm here at OpenStreet. OpenStreet is a training facility used to train OpenReach engineers. What's this here? This is a junction box, and underneath the junction box is where the internet cables are. So we're going to go around the corner and take a look at a junction box closer. You may have noticed these as you're walking around, walking to school. If you haven't noticed it, you'll notice it now, so pay extra attention out. Now, we have Charlotte here. Charlotte's an OpenReach engineer, and she currently works at OpenStreet training facility, and she helps train the newer OpenReach engineers. And we have a junction box here, and the junction box is open. The junction box is open by the box lifter, and that's used just to crack it open. Now, just before they open the box and just after, they've got to just use this tool down here. Just pass me that, Charlotte. Thank you. It's a gas detector, and this is just used to detect if there's any gas. If there is gas, then the OpenReach engineers cannot continue doing their work. Now, Charlotte, would you just open that up for us? This is a node splitter, and this is used to split the fibre cables. Now, we're going to take a closer look at the tubes and what's within them. But I have an example of what a fibre cable may look like here. So this is what fibre is, and this is what will be running through these tubes and underground, and this is how the internet gets from here to your house. And that's all from us today. Back to you, Alan.
Wow. Gosh, so we're learning so much about the things that are going on all around us that we don't know necessarily about. But that's what today is all about. Today is all about finding out about these things, which is why I've brought this chap along here. So, Richard, before we ask you some technical questions, could you tell the audience what it is that your role is here at Exa?
My role here at Exa is I'm the network architect. So I design fibre optic networks for our core network and also for our customers if they're connecting into our network.
So if we were going to ask questions about networks and the internet, you're the person to ask.
Yep.
So we've been thinking about and looking at this internet, this infrastructure, this hardware network of cables. In fact, we've got a cable here on the table. So this is what, copper, fibre, what is this thing?
This is a 288 core fibre cable.
288.
288 glass fibres. So inside this cable, thick, quite sturdy, nice and protected. There's 24 little tubes.
These tubes, they're
all
different colours. They look so pretty.
So they're all colour coded, so we know which tube is which. And then within each of these tubes, there's actually 12, if I can find them, tiny little fibres. There's the tube.
Each one has got 12 others inside.
Yeah, so the tube is the carrier, and then the fibres, you can just about see them there.
Do you know, to me, they look about the same size as a human hair.
Yeah,
and you're saying there's 12 of those
12
inside.
of those in there, and each of those fibres can carry an extraordinary amount of information.
So this is all electronic, like the telegraph, dots and dashes?
Very, very similar. So what we do is we turn light on and off down the fibre very quickly.
So it's not electricity, it's light.
It's light that travels down the fibre.
Right, but we know from science that light travels, like, we don't know much that travels faster than light. So it travels at the speed of light.
Not quite the speed of light. It's about 80% the speed of light because
That's
it's
still
going
pretty fast.
Because it's going through glass, which is a physical medium, not air or a vacuum.
So, like, imagine in some scenario where somebody accidentally cuts through this. Would we be able to see all the light in there?
No, because the light is actually invisible. It's infrared light, and we can't see that. But however, I've got a little demonstration here. So this is what's called a visible fault finder. This is like a red light, and it allows us to actually see. So this is going, this is turning on and off quite slowly, twice a second, thereabouts. And then you can actually see that come out the other end of the fibre. So this could be kilometres, tens, hundreds of kilometres long. The light goes in one end, comes out the other, and because we can turn that light on and off incredibly quickly, probably a couple of million times more quickly than this, we can represent lots of information down the fibre.
So this is slowed down so we can see it, but in reality, we wouldn't be able to see it.
You wouldn't be able to see it.
It's so fast.
And it's turning off billions of times per second.
And it's hidden light.
Yeah.
Right. I'm glad you brought that piece of equipment along. Now, I've heard this thing, people go like, oh, copper's not so good. You don't want a copper network, you want a fibre network.
Well, they're definitely right.
But the first internet in the Victorian time was built using copper wires. Why would you not want copper? Why would you prefer to have fibre instead?
Well, fibre basically carries a lot more information and it goes over longer distances. And it's actually cheaper. Fibre optic cables are a lot cheaper to buy than copper, because copper's quite expensive.
If somebody's internet connection was travelling over copper, wouldn't they want to change it to fibre?
They would definitely want to change it if they wanted faster internet.
And how? Do they just go out? Or is there like a company that can come and do that for them? Yeah.
OpenReach normally, who own a lot of these cables, they're putting in new fibre cables. So if you see people digging in your street, more often than not, they're pulling in new fibre cables, and that will replace the copper cables that are currently there.
Richard, thank you so much
for
answering all of our technical questions about the modern internet. we need to go back to our audience now because we have a Slido for you. So I do want to say thank you to all those schools who have been replying to our polls. Don't forget the Q&A as well, so you can send some questions in. We've already had some really good questions coming in. And one school, Westwood Primary School, they just said hello. So hello, Westwood Primary School. Now, the last question that we've just asked you was, which of these things can you do in less than half a second? We asked if you could blink an eye, click fingers, or send a message. We'll find out the answer in just a moment. So we've just been listening to Richard, who is one of the network engineers, network architect, Alan, do it correctly. And Richard, our network architect, he was telling us about the speed the data can travel at, and he mentioned tubes, not cables. There's me going, oh, the cables. They're tubes when you're talking about fibre. And those numbers, oh my gosh, I was struggling to keep up. He mentioned that each of these tubes has got 24 other tubes inside. And each of those 24 has got another 12 of those individual little strands that look like a hair. 24 times 12. Now he did tell me the answer. 24 multiplied by 12. 288. And did you see that tube? It was, I would say, smaller than a garden hose. You know, in the summer when you're watering your plants and the grass? Well, when you're doing that, and the next time you can go, that looks like a fibre tube. And if it was a fibre tube running under the ground or under the sea, it would have 288 individual little things made of glass about the size of a hair. This is all so fascinating and amazing. Now, I did ask you a question on the Slido. Which of these things can you do in less than half a second? We asked, could you blink an eye? Could you click a finger, send a message? Let's think about that now for a moment. Blinking an eye. So a human blinking an eye. How on earth could you time that? Well, apparently scientists have done this. And they've got humans in a lab and they've used really precise times. If you don't believe me, you can find this out if you search on the web. So a human eye, apparently you can blink 200 milliseconds. 200 milliseconds. Let's do another bit of mathematics. Well, 200 milliseconds, there'd be 5 of them in a full second. So 200 milliseconds is a fifth of a second. That is much less than half of a second. So the other thing we mentioned was a snap or a click of a finger. Well, again, those scientists have helped us out because what they've done in a lab as well, they have also tried to see how long does a click of a finger. 7 milliseconds. 7. That's like, take a second, divide it into 1,000 tiny little milliseconds, and then just use 7 of them for the click of a finger. So that question where we asked, which of these could you do? Well, you could probably do a blink and a click in less than half a second. Well, what about the other answer? We asked, could you send a message? Well, if we are going to try to send a message around, are we talking about the whole world or just part of the way? Well, I think what we need to do is we need to go and talk to somebody called Patrick, and he is going to help us find out how fast we can send a message. Oh, do you know what? I think we need to ask you that first of all. There's probably right now some people in your room and they probably already think they know how quickly you can send a message. So let's ask you. So, thank you for your answers. We're actually going to ask somebody who should really know the answer to the question. Patrick, before we reveal the answer, before we find out, tell us a little bit about what you do here at Exa, your role.
Yeah, so I'm a senior support technician. I work within the support department, the technical part of Exa. We deal with customer problems with their internet, what websites they can and can't get onto, issues with their telephones, internet telephones, website hosting and domain names, and a wide range of technical things that our customers use from Exa.
I'm itching to ask, do you ever get phone calls or emails from people saying, oh, Patrick, my internet's not working?
Sometimes, not that often, but yeah, we do deal with customers who are kind of like really urgent to get the internet back on, because obviously the schools massively use the internet nowadays. So yeah, we get calls from all sorts of customers and emails regarding various things.
And do you ever tell them, have you tried switching it off and on again?
As funny as it is, we do sometimes. It does sometimes fix problems. The old IT switch it off and back on, it does resolve problems, so we do.
It might just be the fact that they're talking to you about the problem helps them solve the problem themselves. Now, we've asked you in to help us solve a problem. We have this question, which is how quickly or how fast can you send a message on the internet around the world? And I bet you can help us answer that.
Yeah, there's quite a simple method of kind of checking times between us and anywhere around the world, known as ping.
Ping?
Yeah, ping, P-I-N-G.
Oh, okay.
Simple kind of tool that you send a request off to a website or a server hosted anywhere in the world, and it'll give you a response time.
So we're going to ask Ping this how we do this?
Yeah, I'll show you now if you want. So
a demonstration. Okay.
We'll use bbc.co.uk website as an example, just to show you how it works.
Okay, so you're going to ping bbc.co.uk just to see what happens. This all looks very technical, looking at your screen now. In fact,
so if we now do that, so we've got ping space bbc.co.uk, hit enter, it sends off the request and gives us a response.
So it's saying 13 minutes, 8 minutes, 14 minutes?
No, they're milliseconds, not minutes, milliseconds.
Milliseconds?
Yep. Super fast.
That's 1,000, sorry, well, that's a second divided into thousands.
Yep.
8 thousandths of a second, that's pretty fast. But we need to remember, actually, the question that we asked the audience was how quickly around the world.
Yeah.
BBC Co UK, it's probably...
That's definitely in England or United Kingdom. So that's just an example to show you how it works.
Where could we send a ping to that would be somewhere around the world?
So I was thinking we'll use the Australian government website. So you'd assume other side of the world, it's Australia.
Okay.
So we'll do the same ping command, this time against australia.gov.au, which is the website of the Australian government.
So ping australia.gov.au.
And then we send that off and we get a response time again.
Right, there's something here that doesn't make sense. These times, they're like even faster than the BBC.
It all depends because we're assuming, because it's the Australian government website, it is the other side of the world. More than likely, the website has got a cached version, a copy that's hosted in Europe or in England. So you get the quick responses.
Right, I get you. So what you're saying is, although this is the Australia government website, it's probably not in Australia. It's like a copy nearby.
It's a copy nearby, yeah.
Right. Does that mean we can't find out the answer to the question?
We can. I do know an IP address of a server that's definitely physically in Australia. So
how do you know all this stuff? I suppose it's your job to know these things.
We know these random things. We definitely know. So we're going to run the same ping command, but instead of putting in a website, we're going to put in an IP address.
So you're typing in ping, but this time instead of typing in words like a URL, you're actually typing in the numbers, the Internet Protocol address.
Yeah, the IP address of a physical device sat in Australia.
Do it.
Off we go.
Oh, now this is different. So we're looking at now very different numbers, 300-400 milliseconds. Yeah. But you know what? It's still less than a second to go to Australia.
No, that's going to Australia and back. So that's a return response.
So when it says 400 milliseconds, that's the return journey.
Yeah.
So 200 milliseconds, it could have arrived in Australia.
Yeah.
Patrick, you've been a great help answering this question. 200 milliseconds. I don't know if you know this, Patrick, but that's about the same as the blink of a human eye.
I didn't, but I do now.
You see what I'm doing?
I can.
I'm sending
I can
messages
see
to
it.
Australia. I'm back. Now, Patrick, you've been a great help, but we do now have some more questions for our audience. So we go back now to the Slido. Like, that is so fast, isn't it? Patrick has been showing us how quickly, or the tiny amount of time you can send a message around the world. And wasn't that a question that we asked you in the Slido, which we'll come back to in a moment? So Patrick has managed to show not just sending a message to Australia, hello people in Australia watching us, but all the way back again in a tiny fraction of a second. Oh, thinking about it now. Do you remember that question we asked earlier? Which of these can you do in less than half a second? Could you blink an eye, click your fingers, or send? You could actually do all three of those together and still have a tiny few milliseconds left over. That is incredible how fast it can be. And that thing as well that Patrick was showing is called ping. Somebody sent in a message and they said, oh, what does ping stand for? Do you know, I don't think it actually stands for anything. And this is where not necessarily the internet, but the web, the World Wide Web, we could do a search later on to find out more about ping. Now, the last time I checked, I think it's called ping because there's a thing you may have heard of called sonar. And if a ship or a submarine is out in the sea and they want to see how deep something is, they can send what's called a ping. And it actually sounds like ping, a sonic ping, and it goes to the bottom of the sea and then it bounces back a bit like our message did. And they time how long that takes. So maybe one day somebody thought, is there a way that we could measure the speed of the internet? Yes. What are we going to call it? Well, we could call it the thing that measures. No, we need some kind of catchy name. Let's call it ping. Oh, like that search engine that might. No, that's Bing. This is ping with a P. Now, you can use ping pretty much on any device connected to the internet. So, I don't know, later at school or at home, you could find a way, couldn't you? You could do your search on the web to find a ping. And did you notice as well? We kind of fell into a bit of a trap. We did a ping to a site that was actually really close. We thought it was in Australia, but it wasn't. So we then had to find one. So you could do pings of all sorts of things. Pings of things. Oh. Now, we did ask you another question. And don't forget, you can be sending in your questions to me because in a few minutes, we're going to have Samia and Richard are going to be joining us to answer some questions. And we've seen the questions you've been sending in, but we can still have more questions, so use the Q&A and send them in. Now, we asked you a question just a moment ago, and the question we asked, it was like a word cloud, and we asked if you can reply to somebody in an instant in less than half a second. Just because you can, does that mean that you should? Well, I suppose that applies to lots of things in life, but, oh, sorry, I know this is a live lesson. What's that? See, how many times have you seen people do that? They're like in the middle of something and then they get a notification, something pops up on their screen, on their device, and we fall into this trap, don't we? We think like, somebody just commented, I have to reply straight away. You probably see it quite a lot. And maybe we could be a little bit more clever, and what we could do is we could create a little bit of a gap, because if we can reply in less than half a second, that gives us a little bit of time to think about it. Think, ooh, that's something we don't do quite as much as we should. So we can reply in a blink. We can reply in less than half a second. But should we? I mean, you can sometimes get messages and you don't even have to reply at all. It's fine not to reply. But there's a message today I'd like you to think. And, I'll work this into a rhyme. So let me see if I can remember. Oh, yes. We can send messages in a blink. But before we do, we should stop to pause and think. I thought that was quite clever. Oh, you don't seem to think so. We can reply to messages in a blink, but before you reply, stop to pause and think. Okay, so we know things can go wrong sometimes when you reply, and you've been sending in all of your answers about, because sometimes you don't read the message properly. Sometimes you send the wrong thing and you're like, no. Now, somebody did send a question, is it possible to delete things that are on the internet? Well, often, once it's sent, it's too late, which is why it's good to stop, to pause and think. Now, in a few moments, we are going to be joined by our experts, but before we do, it would be a good idea to stop, to reflect on what are the things that so far in our live lesson that we have been looking at. Now, do you remember right at the very beginning, I was saying today's lesson is to help us understand all about the internet, this infrastructure, the physical connections that have been around for at least 200 years. And we went over to that museum in Bradford, the National Science and Media Museum, and we learned about how the very first internet used the electronic telegraph, invented apparently by Samuel Morse. And then after we discovered about how you could send messages that used to take days and weeks, but now they could be sent in seconds, we talked about how this infrastructure, it's mostly hidden. 100% of it apparently is under the sea. And some of it is under our feet when we're walking down the streets. And we went live over to Samia, who was able to show us the equipment that you see in them junction boxes, so we can see what it looks like. And then, talking about seeing things, we're also joined by Richard, the network architect, and he showed us, remember he had that demonstration with the fiber, and he showed just how quickly, in fact he had to slow it down so we could see it, and he was telling us it travels at 80% of the speed of light, 240 million meters a second. And then we tested that, because Patrick showed us how, using ping just a moment ago, we could send messages, and you can do the same thing yourself later on. Just remember, ping, and then you can try it. So far, we've been learning all about those things today. Now, there is going to be a moment where we're going to ask some questions of our experts. You still have a few moments to send in your questions and answers to us using the Q&A. So please do that now. Send in your questions. Didn't I tell you we were going to be joined by our experts? You recognise them, don't you? Because I introduced you to them before. We've got Samia.
Hi.
Samia, just remind us what your job is at Exa.
So I'm one of the senior support technicians at Exa. So I help with the technical support team. And I help schools when the internet's down, if they need anything unblocking.
So you work in the same team as Patrick then?
Yes, I do.
Patrick, yes. And again, like Patrick, you get people ringing up saying, my internet's not working.
All the time. I've had a couple this morning.
Really?
Yeah.
Was it really? like some people say, the internet stopped working. Did the internet really stop working?
The internet for them stopped working.
Ah, okay.
The internet overall for the rest of the world was still up, but for
Yeah,
the school, yes, it
yeah.
was down.
And Richard, we met you earlier and you were explaining about how you are a network architect.
Yeah.
So here are some of the questions. Now, some of the questions are coming in that people haven't told us what school they're from, but we have one here. In fact, here's a question. What would happen if the internet went down for a full day?
I think we would not be able to communicate.
Well, we're communicating right now. How would we do that?
Well, we'd be talking, but if you were trying to send an email or call someone in another city or even another part of the town.
I suppose it's like one of those things we take for granted, isn't it? That it's, and all like our phone systems and our governments. But could it really go down for a day? Is that possible?
Not really, because the internet is really widely spread out. It's a lot of networks. So it'd be very difficult for the entire internet, for the entire world to go down. So you might have the internet go down for either part of a city or part of a country or an entire country. So as we saw, I think earlier, where you've got cables that go underneath the ocean, if all of those cables into the UK got cut, the internet in the UK wouldn't be able to speak to the rest of the world, but within the UK we would be able to probably use iPlayer, call people or email people in another city.
This is like this distributed network?
Yes.
Ah, okay. Now, we have another question that comes in. We've had a few similar questions about the energy consumption. So we have one here that says, is the internet bad for the environment because it uses lots of electricity? Somebody else asked, how much electricity does the internet use?
I don't think anyone really knows how much it uses because the internet is made up of fibres. It's also made up of servers in places called data centres. So if you're on a website, that will be running on a server in a data centre, and that server uses power. So it does use a bit of energy, but overall, compared to things like lighting and transport, it doesn't use that much, to be honest.
Now, I don't know if you heard when I was revealing to the audience before that 100% of the internet is under the sea. And that made me wonder, well, if you work with the internet or for the internet, does that mean you have to work under the sea? And we had a question that came in. Somebody says, what kind of jobs are there? I mean, Samia, do you work with the internet?
I do, yeah. I'm a support technician, so there's different types of jobs that's working around the internet.
And like when you were at school, was this something you always wanted to do? Did you think like, oh, when I'm older, I want to work for the internet?
No, when I was younger, I actually wanted to be a teacher. So I did some teacher training. But as I was doing teacher training, I was like, it's not something that my heart was in. And that's when I came across Exa and I got my job here. And since then, I've been working in the support team and I've built my knowledge up from Exa. So before I joined Exa, I wasn't as technical. So I've learned everything from here.
And I have never taught you, but I'm probably old enough to have. Mm-hmm. But I could kind of imagine if you were in my classroom, you'd be one of those people who, whenever people ask questions, you always want to try and help people to get things working. And people say that about you here.
And I like fixing things.
And Richard, again, I haven't taught you, but I'm trying to imagine, what were you like at school? Did you say, I want to work for the internet? Or
when I was at school, in primary school, I don't think I'd even come across the internet. It was only in secondary school that, towards the end of my secondary school, that people were actually talking about the internet. I was actually more into electronics, making circuits, doing wiring, that sort of thing. And then I got into computer programming. And it was only a bit later on that I had interest in kind of combining those things and potentially working within the internet sector.
Now, we've had 3 questions from different people, very similar, asking about the world and like, are there certain countries in the world that use the internet more? Are there any countries in the world where the internet doesn't reach? Do you know about any of those?
Richard might know.
I'm not sure about, I think...
It's a good question.
Yeah, it is a good question. So
Yeah.
I think most countries have some form of internet access. In some countries, the internet may be only within the country. So websites will only load within that country. So you might not be able to speak to the entire world. And in some places that are very remote, where there might not even be electrical power, there may be no internet because there's no power to actually power a device like a tablet or a laptop without even thinking about how to actually connect. But obviously, in most parts of the world now, there's satellites that can provide internet connectivity. But if you've got no power to actually power a device, you're a little bit stuck.
One thing I noticed, I was looking at, I don't know if you've seen, there's this submarine map where you can see where all the cables are. And you can see there's like islands, and some of these islands have lots of connections that go to them. But I wondered, what if you were a country that was landlocked, you didn't have sea around you? How would the internet get to you then, if you were, because you don't have access to the sea?
Cables can go across land as well as sea. So if you're a landlocked country, you would have cables coming across your borders.
And would they be on like telegraph poles or something like that?
Normally just underground. So similar to what you've seen on the open street, there will be fibre optic cables buried underground, but that would go between countries across borders.
Wow. Now, it's possible that after today, some people might have some more questions, and we will try to see if there's a way that we can answer them. Did we have time for one? Oh, we did have. From Dayrimple Primary, they asked, what was the first game that people played over the internet?
Do you know what the first game was? I don't.
I do have to admit, I had to look at Wikipedia. There's a little bit of a discussion about what was the first game to be played across the internet, and difference of opinion. So there was, I think, one called Dogfighter, which was like a plane simulator. But in the early days of the internet, there were a number of different types of games, text-based games. But again, it comes down to what is the internet, because the internet could be your network within your school, so playing games across the school network, and also it could be within a country. So in the early days of the internet, it wasn't so wide, and there were games about in the early days, but yeah, there's a lot of debate about what was the first game, unfortunately.
Well, Samia and Richard, thank you very much for joining us and for answering the questions that the schools have been sending in. So today's live lesson has been brought to you by STEM Live, and people might be wondering, are there going to be any more lessons like this? Well, the answer is yes, and it's so easy to find because you might use the internet, but it would be the World Wide Web, and if you go to the address bar in your browser and go to stemlive.co.uk, you can find out more about lessons like today. So, do we say goodbye to people? Do we wave at them and we're like, oh, okay. Well, thank you everybody else for joining us. If you take any pictures, you can post them using the hashtag, which was STEM Live or Live Lessons, and we will love to see. We'll look at the pictures later on.
We will, yeah.
You might be in a classroom right now where somebody has something like this and they can take a picture of your class and you're all waving, and we will look on social media. But thank you all for joining us. I think we must be getting ready for lunchtime. It must be nearly lunchtime. Thank you, everybody.
Bye.
Bye.